Forgot to record. So take 2. All right, so Unit 7, find the area of non-right triangles. How do we find the area of a triangle? Base times height, not divided by 1/2, because that's like timesing by 2. Okay, base times height divided by 2. All right, or
theoretically it says it.
No. Okay, 1/2 base times height. That's your new favorite word, isn't it? Theoretically. He doesn't even know what it means. 1/2 base times height means in theory. Okay, so base times height divided by 2, or 1/2 base times height. That's how you find the area of a triangle. Now, what has to be true about the base and the height?
You have to have a right angle.
It says that in the top part. Okay. We have to have a right angle between them, right? So if I have a right triangle, like I do right here, which sides could be my base and my height?
A
and B, right? A and B could be my base and my height, right? Okay, because they are
the bottom and the sides.
No.
They're the base and the height.
Okay, we know they're the base and height because these sides are
parallel. Or no, perpendicular.
What is it, Monica? They make 90 degrees, which makes them
Perpendicular.
perpendicular. Good. Now, what if I have a triangle that looks like this, where this is my right angle? Which sides are my base and my height? A and B, right? Base and height, it doesn't depend on how the triangle looks. Okay? The perpendicular sides are always your base and height. Right? That's how you find the area of right triangles. Might have done that last year. Right? What if I have a non-right triangle, such as this one? We cannot cut it in half. Okay? If it was an isosceles triangle, meaning if these two are both 6, then we could cut it in half and work from it that way. Right? But it's not an isosceles triangle. So this is a non-right triangle. Right? So what's my base and my height?
You don't know.
We don't know. Okay? Now for any triangle, the base can be any side of the triangle. So any of these sides, 14, 9, 6, they could all be my base. But if I'm going to use, let's say 14 as my base, then I have to have a height that connects this side to the opposite vertex, Tony, using what type of line? What was it, Mark? Perpendicular line. So I think you were making this motion, Sabrina, but we need to connect A to 14 using a perpendicular line, and that could be my height. Right? Now this is kind of all summed up on the top of your page where it says, remember for any triangle where B is the base and H is the height of a triangle, area equals 1/2 base times height. The base is any side of the triangle, and the height is a distance from a side to the opposite vertex along a perpendicular line. So here's my side, right? A is the opposite vertex. The blue dashed line is a perpendicular line, so that'll be my height. Okay. Now I have 2 examples we're going to go through. The first one is when we're given all 3 sides. The second one over there is when we're given 2 sides and an angle, right? So I left space on your page for you to follow along with what we do. All right. Now the trick for finding the area of non-right triangles is we need to figure out what this height is. Okay, we need to find that h. All right. Does anyone have any good ideas on how we could find that h? Pythagorean theorem. Why Pythagorean theorem, John?
Because you have this all through now.
We have all 3 sides, but this is a different triangle. Right? I made 2 right triangles. Good. So I have 2 right triangles here, don't I? I have that right triangle, right? Or this right triangle, right? So how can I find that height? Okay. 14 squared minus 9 squared will give me that one, right? But is 14 the whole side? No, 14 is too big, isn't it? Right? Does it cut it in half? No, my height does not cut the side in half because I don't want an isosceles triangle. Okay? If these were both 6, hold on a second, John. If these were both 6, then I could cut this in half and say it's 6 and 7. Okay? But that doesn't work in this one.
Use the law of sine.
Okay. We'll get there. Okay? So, since I have 2 right triangles, I can use my right triangle ideas to figure out the height, right? Right? Now I have 1 side length, don't I? So if I have 1 side length, could I find that one? As long as we have what?
All 3
Oh, I heard someone say it. An angle. So we can find this height if we know either C or B, if we know those angles, right? Now looking back at the non-right triangle, okay, so look back at only the black triangle, right? How can I find either C or B? What should I use? Nope. Law of cosines. When you have all three sides, use law of cosines. So in this triangle, we're going to start by using the law of cosines to find C or B. Which one do you guys want to find? C. It's probably the easiest one, right? Law of cosines already uses the C, doesn't it, Trey? Okay. So I'm going to find this C, so that way I can find H. That way I can find the area of the triangle. Okay. So our first step then in this one is to find C. Okay. So find C. So law of cosines is little c squared equals a squared plus b squared minus 2ab cosine big C, right? Are we memorizing that? We're working on it? Already memorized. All right. So to find C, we're going to use little c squared. We probably want to letter our sides. 6 is C, 9 is B, 14 is little a. Right? Now you guys know how to do that. So we're going to do 6 squared equals, that's little c. 14 squared plus 9 squared minus 2 times 14 times 9 times cosine big C. Does that make sense, guys? Yeah?
A lot of numbers.
It is a lot of numbers. Okay. I'll take care of the ones I can do in my head. You guys want to take care of the 2 times 14 times 9? A little ahead of me. 252. Okay. So we got 36 equals 196 plus 81 equals 252 cosine C. Now here, like I said the other day, this is where we make our mistakes, right? We combine the wrong things, don't we?
Yep.
Can I combine the 252 with the 196 and the 81? No. So what things can I combine right now? 196 and 81, right? So we get 36 equals 196 plus 81. 277, good. Minus 252 cosine C. Now what do we do? No. Subtract the 277. So 36 minus 277, what is that? What is it? 25. Church is 25? Okay, I don't think 36 minus 277 is 25. Negative 241. Okay.
I thought you said 277 minus 252.
Okay, we can't do that because this has the C on it, right? All right, so 241 equals negative 252 cosine C. Now do I add 252 to both sides? We divide because it's being multiplied right now, right? So we divide by negative 252. Okay, I'll move it up. So we took negative 241 there and divided by negative 252. Okay, I'll move it over here so y'all can see. So when I divide negative 241 divided by negative 252, we get what? 0.95? 0.96? Okay, so now get rid of the cosine, so we do inverse cosine. So inverse cosine of 0.96. What is it? 16.26. Okay, why did I get 17 when I did this one, guys?
You might have been a radian.
17.1? Okay. 16.26. Did you guys use 0.96?
Yeah.
Okay. I think when I did this division, I used 0.956. I took it one point further, so let's do that. Let's do 0.956. Right. That way I'll know we're right if when we go on. Right. I remember the decimals are really, really important with cosines. Right. So this ends up being like 17.01, right? 17.05. You guys okay with calling it 17? Yeah. Okay. No? Okay, well we're calling it 17, Mark. Alright, so C is 17. Right? So we found the angle. What do you think we have to find next? Why would we want to do law of sines? Well, we have a.
Why don't you just do cosine? Or why don't you just do
What kind of triangle is that?
right?
A right triangle. Right? No?
You can find angle A.
We could find angle A, but it's not going to help us. Okay. Doug? Good. We use sine. H is what to the 17? Opposite. What's the 9? Hypotenuse. So what involves opposite and hypotenuse? Sine. Right? So for our next step to find H, we can use so. Right? It's most likely you're going to be using sine to find your H. Okay? Most likely you'll be using sine to find H in all the problems that we do like this. So once again, most likely you'll use sine to find H. Okay. So sine of 17 equals opposites over hypotenuse. Now don't get confused with the little h. Okay, little h does not mean hypotenuse. It means what? Height. Okay. Why does everything have to start with an h in math? I don't know why. Not everything is just a bad joke. Okay. Sine of 17, what's that?
Whoa, Branch told a bad joke.
What is it, Doug? 0.29. So now I do now. Multiply by what? 9. 2.63 equals h. You got 2.61?
Yeah.
Okay.
9 times 0.29.
Okay. We'll go with 2.61 then. John, you probably used more decimals. That's okay.
I just need 3%.
You take you still right? Yeah, you're fine. Okay. All right, so that's our h, right?
That's right.
Now our last step is to find what?
The area.
The area. Right? So our last step is area. Now area, as we know from earlier, is 1/2 base times height, right? Right? This is my h. What's my base then?
14.
No, you divide 14 out too.
No. 14. Okay.
So whole triangle.
14 is my base. John, if I just want to find this one.
I thought you were trying to split it.
Okay, we're not trying to split it. Okay. Good idea though. Okay. So if h is my height, we have to use the side that's perpendicular to h to find my area. I can't do h times 9 because they're not perpendicular. Okay, I can't do h times 6 because they're not perpendicular. I have to use the side of the triangle that's perpendicular to the h. Alright? So we'll have to do our area will equal 1/2 of our base, 14, times our height, 2.61. So you can type in your calculator, you can just do 0.5 times 14 times 2.61. 0.5 times 14 times 2.61.
Is this on audio?
No, there's nothing like this in audio. What's it, Mark? 18.27? Can I call it 18.3? That way you take care of all the roundings. Yeah? Okay. Does that make sense? And to be complete, since we found area, it should have a unit on the end, but we don't know what the unit is, so you can just call it unit squared. Alright? I'm not too worried about that at this point. But could put unit squared on the end for your area. Alright, any questions on that one? James, any questions? It's Marie. Any questions? No? Davion? No? Okay, the pencil's not even moving, man. Come on. Pick that pencil up.
I'm not gonna be able to read this.
Alright. You can go back online and watch the video again. Yeah. Alright. There's no questions. Let's move on to the next one. Now this one I would say is a little bit easier. Okay? So here we have two sides and an angle, right? Remember in that first one we had to figure out the angle first before we could find the height? Yeah. In this one we have the angle, so we don't need to find an angle. That whole law of cosine stuff, we can just skip it. Okay, we can just jump right into finding our height. Now, since we're skipping the law of cosines, we need to be smart about where we draw our height. Okay, we need to draw it that uses. We need to draw the height so that it's in a triangle that uses this angle. Okay, so if I draw my height over here, is that using this angle?
Nope.
No. If I draw my height right here, is that using this angle? Okay, I can draw right here. Okay, there's two possible locations for our height. We can draw one right here. Okay, where 13 would be my hypotenuse. Okay, you guys see that? Or we could draw right here. Where what's your hypotenuse now? 29. Either one of those will work. Okay? How many is the one outside the triangle? He's one outside the triangle. Okay? So, I want to find this height. So my first step in this one is find h. Okay, don't point to it. Actually find it. Okay. How am I going to find h? How am I going to find h? Aaron, what do you think? What's h to 41? What's the h to 41? Opposite, adjacent, or hypotenuse? Opposite. Perfect. What's the 29? It is next to it. Hypotenuse. All right. So what should we use?
What did I say before? Opposite.
Opposite hypotenuse. Sine. Good. So we should use sine. Right. So we can find our h by doing sine of 41 equals h over 29. Sine of 41 equals h over 29. That's fine, then your hypotenuse would be 13. If you use the first height that I drew in there, then your hypotenuse would be 13. Okay. So using this height, sine of 41 equals h over 29. What's the sine of 41? Give me 3 digits.
0.656.
0.656, good. It was simultaneous too. So now what do I do? Times by 29. 0.656 times 29. 19.02 was h. Okay. So we found our h, it's 19.02. Now can we find our area?
Of course.
Okay. So step 2, area. Now my height is 19.02, right? What's my base? 13. Okay? This whole part is not your base. If I was finding the area of this whole right triangle, then I'd have to find this little part right here. But we're not. We're just finding the area of the black triangle, so we just use the 13 since that's the side of the black triangle. Okay? So we're just using 13 times our height, which is 19.02. So area equals 1/2 13 times 19.02. Has a funny looking 9. Okay.
So it's like ounces.
It does, doesn't it? So 13 times 19 ounces? I'm just joking. All right. So what's our area? What'd you get? 128.33? 123.63? Okay. I got 123.7. Okay. Now Matt found a different area. He's found 128. He did it going using this one. Right? You found 123.656? Okay. So Matt, maybe take a look at yours again. Okay. What was your height going this way? Okay. So if you found this one, your height was 8.528, multiplied by 29 and by 1/2. Okay. Maybe we wrote it down wrong then. Because 0.528 versus 0.58, that's a big jump. All right. Any questions on that one? Okay. Now, looking at these two, which one do you think I like better being your math teacher? I like to have you use as much information as possible in one problem. Which one do you guys think I like better? The first one. Why do you think I like the first one better? Not necessarily more work.
It tortures us.
It tortures you, exactly. No. It takes the law of cosines, right? Which works for what types of triangles? Any triangle. Okay, we mostly use it for non-right triangles. And it takes the SOHCAHTOA stuff, which only works for right triangles. So you got to put them together, right?
Yeah.
So you really have to know the difference between when you can use one and when you can use the other one. Right? The second one, man, you got to be creative to do this one, but it doesn't use as much of the stuff that covered this unit as the first one does. So if you're going to see one of these on a test, which one do you think you would see? The first one or the second one?
I want to see the second
First?
one. You're going to throw the first one at me.
The both? Well, they're both kind of long problems.
I'm going to throw the
Not
first
really?
one at me.
Okay. So you think to yourself, if you were a math teacher and you want to test students' ability on all of the stuff you learned in this unit,
First one.
which one you would put on a test?
First one.
All right. Any more questions?
I put the second one so you can see in the